Hello and good afternoon. My name is Gary Paek. I'm the Intel Americas HPC Marketing Manager. We're very grateful to be here, spending time with you, having great discussions. We've had actually several wonderful discussions over the past less than, 12 hours. And we look forward to meeting with many more of you and having some very fruitful discussions about HPC, what you see, what you'd like to see, where we're going, where you're going, and have some good conversations about intersection points and understanding how we can help. Today I'm going to talk about Intel Scalable System Framework. Before I begin, if I could get a show of hands, how many of you in this room have heard about Intel Scalable System Framework, or SSF? So quite a few, and some haven't. I just want to share with you, I think there's some underlying common themes, and we're addressing those. Some of those common kind of issues, if you will, problem statements that we've heard, such as system bottlenecks, the walls. I think you've heard from previous speakers this morning about memory, I/O issues or interconnect issues, storage. We've heard from many customers about how energy efficiency is a problem statement for them. And as they grow their data centers and their HPC clusters, the performance per watt is a real key concern. Real estate issues, running out of space within their data centers, also performance cost as well is a real concern. And we understand that. We understand that it is a growing challenge within HPC. We're attempting to provide solutions in that space. And we also know that there's a lot of divergent infrastructure, meaning that some customers who will have a visualization cluster. Some customers may have separate HPC clusters. Some customers may have separate big data infrastructure clusters, and then machine learning as well. And all these different divergent infrastructures tend to lead itself to a massive issue in terms of managing the infrastructure and managing the resources, and then utilizing those resources in a way that's effective, going back to the performance per watt, performance per cost. A lot of those, we all know that budgets are very tight these days, and we do know that everyone wants to stretch the data center dollar as far as possible, and we want to help in that regard. And then we've also heard of HPC in the cloud, barriers to extending entry, really democratization at every scale. And I'll talk to you about how SSF, or Scalable Systems Framework, lends itself to democratization in HPC. And so we looked at this, and we're trying to look at it from a holistic architectural approach. Within the system, obviously, there's performance over time, and we're really looking at tighter integration across not just compute, but also with memory, with fabric, understanding how FPGA can be also integrated, tightly integrated into the system, looking at I/O, looking at graphics. And one example of this is our Xeon Phi processor, where we've announced and launched with more cores, with integrated memory, with certain SKUs having integrated fabric as well. And really, that's just the beginning. If you look at what we're trying to do in terms of our innovative technologies and innovation over the course of the last 12 months, in fact, within HPC, it's quite astonishing. If you look, we've launched our first fabric, which is our OmniPath architecture, back at SC15. We did make announcements about SSF with partners several months ago. In addition, at ISC, just a few months ago, we launched our Xeon Phi processors. And then within the ecosystem, on the application side, we've been going and doing code modernization. We call it modern code with our software and solutions brethren. And we're working with the community at large. We work directly with ISVs, such as Altair, who's here, as well as many others. And we also have key task teams working on some of the proprietary softwares as well for our largest customers. Within the community, we have what's called IPCCs, and that's called our Intel Parallel Computing Centers. I believe we're over 70 IPCCs worldwide at this point. And this is all about making sure that the applications are parallelized, that we're all kind of working in a common goal. And then we're doing small things as well. Before the launch of Knights Landing or Xeon Phi processors, we had our DAP, which stands for the Developers Access Program. And that's actually been going very well. We've partnered with an OEM called Coldfax. And the K&L DAPs have been selling very well to, I believe, something like 36 countries so far. In the US, it's to 33 states. So you can tell we're taking a close look at this. We're trying to understand how are we going from a small scale to a larger scale within the ecosystem with reference to software and Xeon Phi. So we're taking a lot of different steps to really look at this from a holistic standpoint. One of the other things that we've been doing, as I mentioned, the launches, we also are, in the software side, have launched Parallel Studio XE 2017. If I could get a show of hands, how many of you have used Parallel Studio? It's within this room. Okay. So what Parallel Studio XE is basically a suite of tools built for HPC developers. And it incorporates a number of different software tools. And it's not just one particular tool. There's just a number of different great tools utilized for Xeon and Xeon Phi processors. It is a portion of our Scalable System Framework, and it's available today. It's also included, for example, with our Developers Access Program. And you can see that there are some rather large highlights. We are focusing on deep learning with our math kernel library and our updated data analytics acceleration library, or DAL. There's a faster Python application. We also, there's a lot of other tools that are incorporated that takes advantage of a number of technologies that we have with, for example, Xeon Phi, and that we'll have with future Xeon processors, such as AVX 512, having high bandwidth memory, and then the vectorization for the compilers and analysis tools. So a lot of different things here. In addition to the tools, we're also having training. We're working with different partners worldwide on training, parallel programming training, online as well as face-to-face. So, for example, I think in the summer we partnered up with Stanford, and we did a 4-week Stanford Summer Series where we actually went through a number of the different tools to help HPC developers and users utilize their performance and take advantage of the performance in their high-performance computing. I believe in October we'll be over at the City University of New York doing some training for parallel programming as well. And if you see a need where your members of your group may need some training around or would request training, come see me afterwards. We can definitely arrange that, whether it's face-to-face or via the web. We can point you to the right ways for parallel programming training. So let me just wrap up. What we're trying to do with Intel Scalable System Framework is a holistic approach to providing you with more options in HPC. SSF really is meant to support many workloads with one framework. The website is there. It's very simple, intel.com/SSF. On that website, you'll be able to look up solutions recipes, a number of different white papers, a lot of information detailing SSF for you. But really, it's meant to support many different workloads. One framework, you're able to do modeling and simulation, for example, high-performance data analytics, machine learning. As Diane Bryant announced at IDF, next year we'll be coming out with Knights Mill, which will be next-generation Xeon Phi processor dedicated for machine learning and deep learning, and also visualization. So we have a number of different things that are in place to support you using SSF within your HPC applications. I just want to wrap up and just say that SSF really is designed holistically. That includes our processors. So compute, think of that as compute. Fabric, so our new OmniPath fabric. software, such as our software tools and also Intel Luster. HPC Orchestrator also, which we announced just a few months ago, just 2-3 months ago as well. That was formerly called Performance Peak. So a number of things are coming together, and we look forward to working with you to incorporate them within your structures and also within your HPC solutions. So things are in the works. Things have been progressing, and we have been deploying actually SSF with, for example, TAC, Stampede, I'll call it 1.5, and future Stampede 2.0 will also incorporate SSF. We have Pittsburgh Supercomputing with over 900 nodes of OmniPath. That's also incorporating SSF. And we have a number of other deployments that are in the works incorporating SSF. And I'll pause there and see if there's any questions or comments.
Okay, I'll make a comment.
Yes.
So, as you mentioned, we had training courses from Intel at the City University of New York. We had 2 last year. Next one is coming up October 19th in New York, Midtown. If you're in the New York area and you want to attend, please go to the Colfax.
There's a site, yes.
And,
It's free to attend, by the way.
And sign up. We'll be happy to have you come.
Great.
But questions for Gary?
I don't want to hold people up for lunch.
So one quick one. Is this going to be integrated in with your VR, AR products?
Can you repeat that? Sorry. VR and AR products?
Right. So the visualization where I have the computing interacted, so I've got
Right.
interactive.
Right. We are looking at integrating into, for example, SD-Viz. I'm not sure if you've heard about that, but definitely we are doing a lot within the realm of SD-Viz, software-defined visualization. In certain instances, we're showing some great performance benefits. That's still in the works, but for future, yes, we do want to incorporate into, for example, using SD-Viz as a means for SSF. So yes, short answer is yes.
Any other questions? Gary, thank you.
Thank you.